Good afternoon and welcome to the Superposition podcast. Today is the penultimate day of the Deep Learning Indaba and I'm joined with my co-host Rebone Meraba. Please can you tell us one highlight of the Deep Learning Indaba thus far?
Oh wow. Hi Emily and hi everybody. Thank you so much for having me. Okay, so far in the Indaba, I'm thoroughly enjoying talking to the other participants about their research. So it's actually very inspiring to hear what other people all over the world are actually busy doing. And yeah, that's one.
Awesome, okay, thank you. Today we are joined with our guests Nando de Freitas and Omoju Miller, and we would like to break down exactly where are we in terms of AI. We're going to talk about the turning points and pivotal moments, looking back at the past 20 years, where we're at now, and where we are going into the future. So Nando is principal scientist at DeepMind. He's also professor of computer science at Oxford and was a professor at University of British Columbia. And Omoju Miller is a senior machine learner at Github and also has a particular expert domain within education. So thank you so much for joining us today, guys.
Thank you.
Thank you.
Awesome. So we would like to begin with a little bit of background. Nando, please can you tell us about yourself, where you're from, and what inspires you?
I'm from Africa. I was born in Zimbabwe and I grew up in Zimbabwe, Mozambique, and Portugal, and Venezuela, and South Africa. I studied in the UK, in the US, I then moved to work in Canada and back in the UK. So the background's a bit unusual. What inspires me is curiosity to understand the human condition, to understand why do I feel what I feel, what do other people feel what they feel, what is consciousness, what is intelligence. Ultimately, I want to understand what it's like to be human, what it is to be human. It's, for me, one of the most profound mysteries that we have tried to answer since we've existed as a species. And that, for me, is exciting enough. I also love to, and it is my hope that along the way, we can make sure that we also help people as we advance this knowledge, and that this is done in a way that everyone has access to it.
Thank you so much. It's very exciting, and hopefully you'll tell us later if we're going to see that in the next 20 years.
All right, Omoju, similarly, may you please tell us more about yourself, and in there, please tell us who has been your role model, either in the AI community or in life.
Alright, so I was born in Lagos, Nigeria. I stayed there all the way through my high school and then went to the United States for undergraduate. And I've been living in the US for probably 22 years now. And while I was in Lagos, I would spend all my summers with my family in England. So it's like Lagos, England, the US. And who inspires me in the world of AI? I honestly do not know. Because I think I got into AI in a rather roundabout way. I think I got into more cognitive science, and I was just fascinated that we could investigate the metaphysical through mathematics, and I just kept on doing it. But if the people that truly inspire me are the people who truly push the boundaries, and one of the people that inspires me the most is Chimamanda Ngozi Adichie, who's a Nigerian writer, and her writing, the way she writes, and she writes a different kind of narrative, a narrative that I recognize myself in her work, and that's something that I did not even know I was missing out on. So that ability to bring your true self to your craft is things that truly inspire me, and I hope to do the same thing. I hope that's what I'm doing when I work in AI.
Definitely, and we're so thankful to have both of you because we have this sense of the true self coming out when we've heard you speaking during the week and when we've seen you previously on other podcasts. So we would like to begin. Nando, you told us on Tuesday that you've been attending NIPS for the past 20 years. So NIPS, for our listeners that don't know, Neural Information Processing Systems, and it is one of the largest conferences in the world in this domain. So please can you give us a little bit of insight to where we were at those 20 years ago when you first begun, and how the domain has changed since then?
It has changed very profoundly. When I started, it was a small meeting, I was a student, and you very quickly got to meet everyone. You could meet even like the big shots in the field because we were just like, a few hundred people. Nowadays you go to it and it's like 6,000, 8,000, all the corporations are there, media, etc. It's a completely different thing. And in terms of how it's changing, at one stage it was an academic endeavor, basically. It was mostly people who wanted to understand the brain and intelligence, consciousness, and so on, would sort of get together and work on these problems and we exchange ideas, and it was a lot of fun. And we also, NIPS always happens in a skiing resort, so we would basically go skiing a lot of the time and socialize and so on. Nowadays, and especially what really has happened, it's not only in terms of breakthroughs in terms of ideas, but computation came of age. We saw the microprocessor, you know, it's been a revolution. It's like in 20 years, we've seen how computers have grown vastly, and how we went from the 4 meg of RAM, which is what I used when I was here as a student, to you know, so God knows what people are using now, thousands of machines in parallel with terabytes of data and so on. And so the computation, the onset of the GPUs, and now recently new products like the Google TPUs and so on, the data being accessible. Whereas before, when I started my PhD, you would have like 6 images if you wanted to do a PhD in computer vision.
Wow.
6 images?
6 images. 6 images is like your big data set.
Yeah.
And the way we did it as well was that we had different tools. You do it with geometry. When I started doing my PhD, 96, I remember it was like, I was very frustrated because I'm like, how can I use geometry to describe trees and the sort of things that I see in everyday life? And so learning seemed to be the way forward. And it was, but it wasn't clear how how long it was going to take to succeed and so on. So it was computation and data that made it possible.
And on that data point, we can also speak about ImageNet. So the availability of suddenly millions of images from Feifele, I believe.
Correct.
So would you also say that now is a turning point? That was a turning point, making data accessible. Was that the first that you'd seen, or were there other initiatives to actually put that data open source so that people could research on it?
I would say it's actually, because I'm writing a blog post that one day I would finish. When I started my PhD, I did a PhD, this was going even back to my master's in like intelligent systems. This was like 2001, 2002. We would do work on neural networks, and it was painful because you had to write everything from scratch. It was on C and C++. You had to implement everything from scratch, like a tensor. Everything from scratch. This was just painful. And I was just like, I'm not doing this anymore. This is not lovely. I'm going to symbolic logic and declarative logic where I can just like say things in Prolog. That's it. No more tensors. Now we have, in those intervening 20 years, we have open source libraries with lots of frameworks that has made machine learning research and machine learning in production quite feasible. We have the invention of the Python scientific stack. We have the invention of NumPy, which is this library that helps you do the tensor mathematics. We have pandas for data frames. We have matplotlib. We have SciPy. All these things. We have then scikit-learn that came out of Google's Summer of Code. All these frameworks, now with TensorFlow and PyTorch, it's so easy now because you actually have all the frameworks from a computational standpoint there. You have the ubiquity of the data sets. You could just put it together very easily, and then you can play with it more. So it's easier for lots of students to get into the field now because it's not as torturous. It's not just C, C++ and MATLAB. You can just do a lot of stuff in Python and repurpose people's work. So that also helps a lot. And then, of course, the ubiquity of data with cell phone and sensors and all those things. We just have so much data that we now can actually see. If you're outside of a Google or something, if you're just a regular person, you can get enough data to actually see the power of these algorithms. Because the algorithms are not quite new, but it's the ubiquity of computing data.
Great. So we've looked at the computational power, the data accessibility, the tools accessibility. How about in terms of research and innovation within research that has really changed the face of computer intelligence?
I think there have been some important innovations, but at the same but I do think that by and large was, as pointed out, the revolution in software, in the GPUs, because an experiment would take a month. You know, it's not like we weren't doing COVNETs for video and so on, but it just would take too long. And so there wasn't, so it would take a student doing a PhD, so that the student would only be able to do 5 to 10 experiments. Whereas once we were able to do it overnight, then all of a sudden you could start experimenting and do all sorts of things. So the onset of the GPUs into around 2010, so I was part of this Canadian Institute for Advanced Research, where Joshua Benjo and Jana Cohen and Jeff Hinton and Andrew and I and many others met. And we knew this. We knew we had to harness GPUs. We had a few workshops even before the ImageNet success. And then it was Jeff who was the first one to sort of succeed and get the big media story. Deservedly so, because he was very smart. He knew that was the sort of direction to go, and he had amazing students that made it happen. There've been some innovations since then, mostly thanks, as you pointed out, to all the software, because with tools like Torch and so on that come from some folks like Leon Botton, Jana Kuhn and so on, that developed this idea of doing everything in neural networks in a modular way. You know, that led to the creation of Torch with Korai and colleagues. And soon enough, everyone was it's like I mentioned in my lecture, it's like Lego.
Yeah.
We gave people Lego pieces and how to put the Lego pieces together. And then it just exploded.
You kind of, we've gone from the history, we've spoken about where we are now a little bit as well, you've touched on the engineering and the creativity. How about your own personal interests within the field? So Omoju, maybe we can begin with you.
So even with the history that we've spoken about, I think it's a history of statistical learning that we spoke about, not necessarily AI.
Okay.
Because they're not quite the same thing. It's more deep learning that we're talking about. And there have been different kinds of AI that people have done over the years. And some of them have kind of fallen out. So the kind of AI that I used to do was declarative logic, first as a predicate logic. It was around expert systems and reasoning systems. And it was rule-based and all these things. So it got you far, but it didn't get you as far. And then we have the statistically based approaches that gets you even further. I actually think now that in the future, we probably should have a bit of both with this program synthesis thing. Like there's still something from the old ones that we can bring to the new and merge them together in some kind of way to get us even further along. And those are the kinds of things I would like to see happen more. I would like to see more of program synthesis. I would like to learn how to think about writing code. So I do mostly machine learning on code. So it's an interesting thing because I think it's almost like a subset or a variant of NLP, but it's not human-based language. It seems bizarre to say it's not human-based because humans write it.
Yeah.
But the norms around the language is very different. It's bounded. It's like a tree-based structure. And therefore, even the way people write code now, most of us write code from scratch, which with all the data we have, we shouldn't actually be doing. We should just think about what we want to do and figure out what are the right set of queries for me to do to reproduce, to get functions that do exactly that and then combine them together, especially if the functions have been thoroughly vetted and very productive. Like the way we even think about solving our problems are 19th century, 20th century ways, because our tools have changed, but we still reason and solve our problems like we were still in 1987. Because all the things are there now, so there's this behavior change that needs to happen to all of us. And the best way to see that is to actually watch children engage with technology, because the way they engage with technology, I still type. That's my first mode of typing. And I watch people like my son, they don't type. They just talk to the thing. And they get to it faster. And I'm like, I could speak to the thing.
Yeah.
And I would still I could just say my query and the results will come up. Why am I still typing? Because I'm used to it. And even writing code and doing exploration, there needs to be a change in that too, because we have so much more options, but we're still doing things we do in the other way. So the kinds of things I'm looking forward to doing is to actually figure out ways to help us all change our behavior. And then from where I sit at a place like GitHub, build the tooling via machine learning to support all those things. Because my biggest goal is to continuously reduce the barrier to entry so more people can come in and start doing more fun stuff. And just evolving software and how we write software around this helps me do that.
Okay, great, thank you. And Nando as well, some of your personal interests at the moment.
It continues being to understand the brain.
Yes.
The only reason why
Yes,
this is the main reason why I do this. I really want to figure out what we are.
Okay.
And so everything, it's like, how do we have concepts of things? How do we can compose concepts? How can I say, imagine a unicorn with zebra stripes and I know owl wings, and we have no trouble imagining that. But these are things that don't even exist in the world. And how did we get here that we became a species that was capable of this type of abstraction that allows us to be talking here using language? I'd like to understand more about imagination. I'd like to fundamentally understand consciousness. What is consciousness? And so
Just the
these
easy
are the
problems,
big,
guys.
these are the big questions. They are hard problems. Probably it might be in my lifetime I'll never see the answers to them. But that's what excites me.
Yeah.
That's what excites a lot of people around me.
Do you think it's
fun?
possible? So I think I read Jefferson's computers, it took 16,000 computers to recognize a cat. And when I heard that, I just thought there's no hope to actually like underpin consciousness, given that it requires so much resource at the moment to understand a cat. Humans are doing this constantly.
So I think the biggest stumbling block now is not so much in terms of the computational resources, but to make progress in consciousness, but there has to be progress in conceptual progress. Just like a few decades ago, we didn't know what computation was, and all philosophers were arguing about what might be computation. It was a sort of vague concept. And eventually, with Turing and a few others around the time, it became concrete. And so nowadays, we don't think of computation as this esoteric thing. I think eventually we will get there with intelligence, awareness, consciousness, and so on. Causality is another problem that really interests me, and I think it's a very important one.
Can you define causality for us?
Yeah, I'll define it with an example.
Okay.
So imagine that you have a setting where there's a rooster, and the rooster sings, and the sun comes up, and some farmer comes out and sort of plows the field and so on. And then the next day you see the same thing happening, and the day after and the day after. So if now the rooster sings and asks you what's going to happen next, you're going to say the sun's going to come up, right? So this is what almost all neural networks do now. They've learned these correlations. What happens and then what happens next. And this is what leads to all sorts of problems that we're seeing now with bias and so on, because we've only learned correlation. The neural networks don't go and do experiments like, what if this rooster was not allowed to sing today? Maybe let's bandage the rooster. Oh, look, the sun still came out. So maybe the rooster is not the cause of the sun coming out. We have this other area called reinforcement learning, where we do intervene in the world. We act upon the world, so there's actions, and so we can sort of acquire causal knowledge. It would be interesting to see more work on I did that and I got here. Had I done something different, where would I have gone? To sort of counter to the fact what could have happened. Had I done this experiment different, had I collected data differently, what conclusions would I've reached? our machines are not capable of doing this routinely yet at the scale that we see the deep nets working these days. That is a fascinating research problem, and also I think a very important one in terms of governance and ethics for AI.
All right, so like with that said, right, as a young scientist in this AI community, can you like explain to us what is currently happening? What are the current things what am I walking into? What are the hot topics that people are researching?
I think he spoke a lot about them
Okay.
already. Like,
Is there anything you want to-
reinforcement learning, GANs.
I think what you were speaking about now was,
GANs.
it sounded like GANs, general adversarial networks, in terms of changing the...
No, I would not. Probably not. But what I like, some of the things that what we're getting into. Perhaps I'm thinking about things that don't even quite exist yet. So we have our statistical based models, deep learning, our deep models, and on top of that, there has to be some kind of pruning to still evolve some set of rules or something of a bounded thing that you can then do simulation on and actually explore the different paths and possibilities. So you get all these things, you prune something, bound it, and then you just do all the paths, almost like a search. So you can figure out the different scenarios. Just doing something like that would be amazing. And getting people to the point that they can just see it in their mind. Not math, like just reason. And see it and just feel like, and try those things that we don't even know if they are words to explain them, but we can just do them and see what happens. And if nothing happens, oh well, and then try it out in the real world. So I think the interesting things are like there's lots of stuff happening in deep learning. Reinforcement learning, GANs, but what I find more interesting is actually understanding. What I find the most fascinating is this bias stuff.
Yeah.
How do we correct for that? Can we correct for that? Should we actually go and get this data that's generated by humans and just mix the data up, resample it, and then use it? And then all the things that says about us. Because when you think about, should we do social engineering? Because that's basically what we're basically coming down to saying. Do we want to create a world that we want, or do we want to reflect the world that is?
And social engineering is already happening within some like marketing spaces. So it's already at play, but maybe that's not explicitly told, like you've got your Facebook, you've got your recommender systems, you've got suggested friends, so it's already taking place. So like how can we then put it into the space where we're using it to, remove bias or to go against the bias which we already have within us in the society?
That one is very interesting because it's happening but we're not quite aware of it. So the intersection of philosophy, a certain version of morality, and computer science and AI. So I want to see more interdisciplinary expertise because the problems we have now are not just mathematics.
Sure.
It's not the math, it's all these other stuff that we're like, I don't know what to do. And you've got to make a decision because you're building a system.
Sure.
Just a small little thing you put in your system changes the outcome. Should I really, and the evaluation metrics of my success, engagement, should I actually perhaps recommend friends to you that are completely outside of your sociological bubble?
Right.
Would you ever, can I optimize the framework in such a way that you might eventually click and make friends with that person? Because now that's the power that I have as a designer of the system.
Yeah.
And will I be rewarded for that? Will engagement actually surge? Or as a company, am I willing to lose money for a few months to actually see if this thing will take off? So these are now all market-based, moral, philosophical questions around the tools. It's not even math anymore. It's just, I don't know what the word is for this thing, but that's where we are.
Yeah, and I think there was like a law in Germany where they outruled any bias being coded within the autonomous driving vehicles. So now it's like you can't actually choose to rather, run over this 80-year-old woman who's maybe got 5 years to live versus this young budding Rebone Meraba, data scientist coming up. So that's like a really interesting law which has been put into place to address the morals and ethics of where we are at data science.
Yeah, but it's like, whose morals? Whose ethics?
Correct.
Whose morals? These are just hard problems.
Mm.
Who gets to define what is
What
there
is morally
actually
correct?
this is the thing that got me interested. Now we can get back to, is there actually a universal morality that all humanity share? I mean, because that's basically, at some point you want to build a product that scales globally, and you don't want to do like have a 10,000 versions for each country. I mean, you could, but that's like, just if you could build something that could be easily adopted globally, it's easier. But then you get to this question of, what are the universals, and what are the things that require localization? Those are the things I find as a young scientist. I think that's the world you're working into.
Okay.
You're gonna, at some point, you can't get away from these things, because you're gonna have to decide your research. You know, where do you publish your research? Where do you get your data set from? And how does your research actually scale? These things you're going to have to answer, because somebody might take your research, someone like me as an applied scientist, I want to use it, and I'm going to come back to you and ask you all these questions, and then we're both like, ooh, we've not thought about that. So that's the world you're entering. But that's why it's fun also, because there's so many questions with no answers.
Okay.
I'm really glad you mentioned about representation, because now we're in South Africa, we're in Western Cape, we're at the Deep Learning Indaba. The Deep Learning Indaba is saying, let's strengthen machine learning in Africa. So how, you know, in terms of talking about the bias in the systems, how is Africa being represented in the computer intelligence space at the moment?
Africa has been absent.
Yeah.
Actually, before I came to the first Indaba last year, I was at a big natural language processing conference. I asked the audience how many participants from Africa. The answer was 0. A few years earlier at NIPS, there was a slide with numbers of people and which continents they come from. Actually, this happened several years, and for Africa the number was always the same, 0, not 1 or 2, but 0. This year at NIPS there are papers from Africa by Africans out of Africa, and so there's been a lot of progress. It's exciting. Yes. I'm very proud of my colleagues here for having taken that step. It comes not just it's not just a question of the outside world like stopping us from participating and so on, or there being biases, but it's also about people in Africa recognizing that it's important to be publishing at these venues, that these are the venues that that we all use to compete, the rest of the world uses to compete. We can't have local journals counting as much as a publication at ICML or NIPS and so on, because those are the things that matter, those are the things that people care. In fact, you could just put your paper on archive and you would get more readership than if you, and especially if you put your code on GitHub and so on.
You'd get so much more use. I was telling Nando as we're walking over here that one of the things I would really like, all conferences and journals, whatever it is, if you're publishing work and it's computational based work, you have to also publish the code, because we have to be able to reproduce your work. We have to know everything that went into doing your work. We actually have to verify
your code.
Yeah, and I don't think we verify now. We just assume it's true, but we don't know if it's true, and we don't know true under what conditions. So reproducibility. And the African context is also quite important. If we'd been at the table all along, we would have generated different kinds of data sets, just because of the demographics of our population. But it's never too late. We're catching on, and we're getting into the conversation.
I think the important thing is we're nearly 17% of the population. So any corporation will see Africa as a huge market.
Investment.
And if the corporations don't invest now, they will miss the opportunity.
Yeah.
So it is within their interest to pay attention to Africa.
Yeah. Yeah, I mean, hopefully they'll invest whilst maintaining and respecting the data that is accumulated from the continent, and also the intellectual property that is harnessed.
True.
Yeah. Okay. We would also like to know, where Africa is now, we've spoken about it. How about into the future? How do you see the integration of Africa with the spaces that you are in at the moment, and the role that your institutions and frameworks will play in this strengthening of Africa and machine learning?
This is a very interesting one. So Mustafa Sisse, who's a research scientist at Google AI, he was just talking about in 2050, the population in Africa will be 2.4 billion people, majority of which will be very, very young. So that's a lot of people. And so if we're thinking about people who are just going to participate in AI and computation, a big chunk of them are going to come from our continent. That means we have a very unique opportunity to kind of shape the future of artificial intelligence and the kinds of problems that we're solving. 2.4 billion people in Africa. Currently Nigeria, I am from Nigeria originally, so Nigeria is like 180 million people in a country the size of Texas. It's not a big place, it's small, but a lot of people live in it. And by 2050, some are saying that 180 million will be 700 million. So that's a very, very unique opportunity, because can we actually sustain life from this small place for 700 million people? We have to have advances in agriculture. We have to have advances in just so many ways of how we build homes. The ways we build homes have to change. Our agriculture has to change. Food consumption has to change. Health has to change. Education has to change. So basically the kinds of things we need to do will require some kind of distributed systems approach. It's not going to be enough for one person to sit down with 20 kids. You're not going to have enough classrooms to have 1-to-10 ratio. Because how big would that school have to be? How many physical schools will you literally can't build enough schools to educate the students. Forces you to actually say, all right, what can we actually use here? Technology. Perhaps you don't physically go to school. Maybe you go to school once a week, but you come together in your local community in learning cells and just learn together in a distributed fashion. So we are forced to invent so many things that the rest of the world is going to benefit from. And because of 2.4 billion people, that's lots of data. If we're going to do pattern recognition and data mining, that's a lot of data that we can find things. We can run all kinds of experiments because we literally have the volume to figure out what works and what doesn't work. So I think the future is going to not look anything like what it has been, because it's going to be so radically different and it's forcing us to invent. And so hopefully young scientists like yourselves are thinking about that kind of future and thinking ahead, projecting. Whatever solution you come up with, think, does it scale? If it doesn't scale, kill it instantly, because there's no point, because you're going to have to scale to be able to deal with the population that Africa has. It's very exciting, because then we're going to really see AI in education take off, because we're going to have to.
Wow, thank you so much for your insights and just to share with us and with our viewers and listeners about your experience in the field. Rebone just has some personal questions to ask you to finish us off.
So I just want to understand, like, how do you guys keep the balance between work, research, life? Like, how do you, Omoju, can I start with you? Like, how do you bring balance in your life?
I do self-care Sundays. I'm the queen of taking care of myself. I am, and I see this as a very high priority. If I truly believe I have the capacity to solve a lot of problems, then I must take care of myself, because I want to be around for as long as possible. And I also want to have the mental energy and the capacity to actually carry out the solutions. So I then have to literally take care of myself, because if my body falls apart, none of this happens. And so I built little things into my day or into how I live my life to ensure that. You know, we just take a shower, I do my makeup, because it forces me to slow down and to personally care for myself and to reflect upon myself. Am I loving myself? Am I caring for myself? And on some days I would go to the gym, I go to the steam room, I just relax and turn things off. And just turn things off. And if it gets too heightened, maybe once every 3 or 4 months, I may just stay in for a weekend, where if I'm alone, then I don't even speak at all. Like this, I don't even use the voice. I just stay in my own mind and my own head and just shut everything down so I can be powered again. And I do that systematically, otherwise I will burn out. And burnout if you burn out, you don't actually get to solve your problems.
Fair enough.
And so it just has to be a discipline.
Relax.
I mean, and I think this is a kind of education we don't teach.
Yeah.
We don't teach the
Definitely.
financial literacy, the taking care of yourself, the good diet, the things that you literally need to be able to actually achieve, to solve your problems.
I think because we're so like trained into being a perfectionist, you just want to do your work. Excellence.
But if you're not taking care of yourself, you're not going to. It's not about. It's about sustained excellence, not some kind of crazy zen down. It's sustained. We're in a marathon. I probably will live for 125, 150 years if things go on with life extension. So, if your body might be alive, but your brain has crashed. So the world is changing. Even the world is literally changing, and we're not catching on to it, and we're not valuing the things we're going to need, and like caring about ourselves. So we can. You might be alive at 80 and still have the body of a 50-year-old, so you can actually do all the work you want to do, but you've not thought about it. And now you're like, oh, I didn't know things would be like this. I actually think we're going to be living in that world. So it behooves us to figure this thing out so we can actually move faster in a sustained way and we don't fizzle out.
Okay, thank you so much for that advice. Take care of yourself, Emily.
This is what I will be doing on Sunday.
Going to gym.
All right, and then Nando, to you, may you please share a piece of advice for us and the listeners as we journey on into this AI community?
It's like that piece of advice from Nike. Just do it.
Okay. If it's scalable, just do it.
Yes, and take care of yourself.
Take care of yourself.
Yeah, and scale.
And actually, this is where AI comes in, because AI is what our human minds are limited. Even like issues that we've been looking at, like economics, politics, and so on, we're just seeing it more and more. People, a single person, your leader, is incapable of understanding the whole economy of a country. And even a small group of people cannot do that. Your political party does not understand the country, and that's why sometimes they don't get elected. Machines offer us the ability to extend our cognitive power, to be able to do much more. And so the ultimate hope of AI is to harness AI to be able to attack these really complex problems that people have struggled to solve. Problems like, how do we take care of our environment? How do we take care of ourselves? How do we make sure that we deal with growing populations, moving populations, the fact that country borders are changing over time? These are the wonderful things that make me personally be very excited about AI.
Thank you so much. We're very excited too, and thank you so much for sitting with us. Thank you for joining us at the Deep Learning Indaba and sharing your knowledge with us. We really appreciate it.
Thank you.
So much.
All right, thank you for tuning in,
Oh.
and we will drop you some links about information from our speakers at the end of the podcast. Thank you.
We got 25 minutes for lunch.
Thank you so much.
Joanne ran for lunch.
Yeah.